Hello, everyone. We are happy to bring to you the recording of the 13th webinar of Energy Evaluation Asia Pacific, where we dived into the fascinating world of artificial intelligence and its role in the evaluation of energy programs and policies. My name is Nazir. I serve as a coordinator with Energy Evaluation Asia Pacific, which is a vibrant community of energy and evaluation professionals across the Asia Pacific region. Before going to the webinar, I would like to quickly introduce Energy Evaluation Asia Pacific, or we call it EEAP, to you. So EEAP is a non-profit organization established in 2018. It's modeled after the International Energy Program Evaluation Conferences, active in the US since 1983, an International Energy Policy and Program Evaluation Conference, which is active in Europe since 2010. EAP is a community of energy and evaluation practitioners focused on expanding the practice of objective evaluation in the Asia Pacific region. Its geographical focus spans all the way from Pakistan to New Zealand, covering some 30 countries in between. EAP's mission is to take a leadership role in expanding the practice of and capacity for objective evaluation of energy efficiency and renewable energy programs and policies. EAP brings together individuals interested in energy evaluation across the Asia Pacific region by fostering a robust network of practitioners and stakeholders in the energy sector, sharing a comprehensive database of resources on international best practices in energy evaluation, and hosting online webinars that focus on development and skills in specific aspects of energy evaluation. Additionally, EAP organizes international events such as regular conferences in the Asia Pacific region to further collaboration and knowledge exchange among energy evaluation community. To learn more about EAP, please check our website and social media pages. Now, let me invite EAP Steering Committee member Anindita Sharma to share with you more about the webinar on artificial intelligence and evaluation of energy programs and policies.
Hello, I'm Anindita Sharma, a steering committee member of EEAP. Welcome to a recording of EEAP's recent webinar on AI and energy evaluations. This was just the first conversation about the intersection of two mega topics: artificial intelligence, seen as the most important event in human history since the internet happened, and energy, the one thing that touches or powers every single human activity. In the video, you will hear from three speakers: Ed Vine, Haidar Khan, and Laura Gagliardone. Each will touch upon AI and evaluations, but from a different vantage point. Ed's perspective is from his 44 years in evaluating energy efficiency and renewable energy programs and policies. He provides us the backdrop for AI in evaluation, talks about pros and cons, and leaves us with this question: when should we not use AI when we evaluate something? Haidar's presentation is about the work he and his colleagues in ICF are already doing with the private and the public sectors in programs and in policies. In his presentation, Haidar's, you will find a very clear focus on AI use cases for energy evaluations. He talks about different AI models, starting from large language models to digital twins, the latter with great potential in energy evaluations. And finally, Laura will end the presentations with her perspectives from her M&E and implementation experience with 7 UN agencies and numerous NGOs. She provides considerations and examples. Most of all, she presents her 4-step framework for an organization to consider as they incorporate AI tools into their own work. I also encourage you to listen to the Q&A section in the end, where the speakers will answer audience questions and suggest AI tools that evaluators, energy or other, can start using immediately. Finally, please connect with us, email us about your questions or comments, whether it be about this webinar or another that you've seen with EEAP. What else would you like us to talk about, whether it's this topic or another topic? Thank you again for your time, and we hope to meet you again in our next webinar.
This came out of the last year thinking about AI and hearing about it and wondering, well, what does it mean for me? In particular, me being an evaluator of energy programs and policies. And there wasn't much talk along that framework. There's lots of talk, and even more so almost every day, about AI and what it means for people. But in terms of our profession, there was very little. There is now more talk about evaluation, particularly in general and of other programs, but not on energy program and policy. So I thought that it'd be good to have a webinar on this. And my presentation, as noted, is about setting the stage and some guidance for evaluators. So, you know, the future of AI, it's in the future, but now it really is here. And I think everyone understands that. And there's concern about what the impact will it have? Will it transform every industry? Or is it going to end the world, or both? And we don't have the answers today, but hopefully we will start getting closer to where we want to head. And I have these topics to, again, help set the stage, and I'm hoping the other speakers will discuss some of this as well. So what do we mean by AI? How is it used? What are the benefits? And then in particular, what are the ethical and social issues related to that? Is human expertise still needed in evaluating energy programs? What kind of education is needed? And then there are opportunities for collaboration, reflection, and I've added some references I think might be helpful for people just starting out on this venture, and some concluding thoughts. So in terms of definition, it's a very simple one that I've seen and I'm using here. It's the theory and development of computer systems able to perform tasks that normally require human intelligence. So think about everything you've done, and then think about AI coming in to do some or perhaps all the tasks that you've been doing. And I think of AI being used at the design stage, how it can assist in learning about topics, summarizing RFPs, outlining proposals, drafting needs assessment, supporting logic model development. As you know, there's lots of interest in the last 5 years, I would say, in developing these logic models for all the evaluations, performing literature reviews, drafting evaluation questions, and preparing project materials. And we'll get into more detail here.
I would like to remind, please? Yes, thank you.
AI can assist in data cleaning. AI can assist in data cleaning and review, recoding data, providing assistance to any of the languages you use. I, for example, is an Excel person, so that can help in both designing the Excel and implementing it, and developing visualizations, suggesting key insights for different audiences, and tailoring communications. So there are a lot of benefits, as you can imagine, knowing what AI can potentially do. One is efficiency and accuracy. So it helps you automate and optimize tasks and processes. And some examples in administrating surveys, coding data, identifying patterns and trends, generating insights and recommendations, and creating visualizations and dashboards. Of course, you could do one or more of those, but this AI does it much more quickly. So it saves time and resources. Hopefully it reduces human error and bias, enhances the quality and reliability of data and findings. It also, a benefit is innovation, creativity, helping you innovate and create new ways of conducting as well as presenting your evaluation to the stakeholders after the evaluation has been completed. So as you can imagine, you use AI to explore new data sources and methods. You can generate novel questions and hypotheses, as well as test different scenarios and assumptions. And you can use it to communicate and engage your stakeholders in more interactive and dynamic ways. You can also increase efficiency, remove bias, and improve trust by analyzing, categorizing, retrieving, and translating text across multiple languages. You can use it to draw from past evaluations. As you know, we have thousands now of evaluation studies. It'd be hard to go through each of them and try to summarize the results from all of them. AI can potentially do this. And it can help eliminate selective bias that when we rely on manual human-led approaches, what data sources to use or not use, what reports to look at or not look, etc. We can analyze context and we can also track progress using AI, another benefit, supporting particularly tracking real time and reporting on program results, enhancing transparency and accountability. And then finally, knowledge sharing. One of the key attributes of the evaluation enterprise is to share what you've learned and to give access to information that is really most relevant and useful. And so you can do this by writing articles, but you can do it through images, social media, raising greater awareness about what has been found and improving the communication between different divisions and offices. So the question is, are we ready for AI? We can think about the first light bulb transforming the world with light, the first automobile, the first phone, internet, and now social media, how that has transformed what we do. It's really mind-boggling. So the question is, how will AI change what we're doing? But we have to keep in mind there are ethical and social issues involved with AI. We have to ensure the systems are transparent, accountable, and fair. They respect the privacy, dignity, and rights of the participants and clients where information is extracted as well as distributed. We have to beware of the potential risk and harms of using AI, such as data breaches, manipulation, dissemination, and displacement. We need to balance the use of AI with human judgment, values, and participation, because human judgment will definitely be involved, as I mentioned earlier, in the type of data that's collected and where and when. So we need to avoid over-reliance or misuse of AI, and we need to cross-reference, check, and verify output. And the word people use these days are hallucinations. We rely on the results from AI without realizing it may have presented false conclusions. So we really have to check whether the conclusions are valid. Intellectual property is key. AI will be collecting, as you can imagine, tons of data and paper, etc. Who owns that? Do the people who provide that without their knowledge, for example, own that? Or does the owner of the AI and the evaluator own that? We need to make sure about the quantitative and qualitative validity of the results. And we have to make sure that what is collected and predicted, that there is internal validity to make sure it's accurate and true. And then there are barriers to access. We have to make sure that some data may be more accessible than other data. So that may prejudice the final results from your study. And then related to intellectual property, privacy unknowns, what happens with the user data? How is it managed and collected and secured and stored? And who is it shared with? Very important questions we need to know before the exercises are conducted. And then how to prevent biases. I've implicitly referred to some of the problems that may occur in representation. Is everybody being, is data on all your audience being collected, or only certain segments of that audience? Is there measurement bias? We're all familiar with that. And then other errors, including factual error. So how do we limit the potential harm? These are key issues we need to focus on. So as you can imagine, we can't just let AI run amok, as it were. We need human input. And the human input is going to be essential in thinking critically about the evaluation, what needs to be done, when, where, for whom. We need to apply it appropriately. We do still need to set goals. AI should not be setting goals for the evaluation. It can provide input for that, but at the end of the day, it's the humans who are going to be setting the goals. We want to make sure our ethical values are guaranteed. We definitely need to involve stakeholders. People have heard me talk about stakeholders in evaluation. They're involved not just at the end, but even at the beginning of the evaluation. So they need to be involved and kept abreast of what's going on throughout the evaluation, as well as at the very end. So we need to be curious, but we need to be responsible. So as you can imagine, education is going to play a critical role. And that's why I think energy evaluation in Asia Pacific will have an important role to play as well in educating evaluators about AI systems, and so we can maximize our benefits and minimize our risks. And evaluators in the future, I think there more and more will be taking these online courses, reading blogs and books, watching webinars like this, as well as podcasts, and joining communities and networks related to AI and evaluation. It's important to try out different AI tools and platforms, which I'm not talking about here, but very important to do that. Apply AI to your own evaluation projects, either as a pilot or a complement to your methods. And very importantly, collaborate with peers. Joining AI communities if you've decided to get more and more involved in AI, because you need to stay updated on the latest research. So we call this, workforce training, but I think we'll see more and more webinars, and perhaps conferences will have special sessions on this as well. And then finally, combine learning with practical experimentation for a comprehensive understanding of AI evaluation. So you on your own, you might do some experiments with AI, like you may already be doing that for other reasons, like where's the best places to visit in Paris, and AI will tell you that. So those kinds of exercises as well will be very important. And then once you do that, some of that you can do on your own, but you definitely need to collaborate with your peers, your friends, your colleagues, and seek advice and feedback from the experts and mentors, as well as sharing experience and lessons learned, and participate in events and forums related to AI and evaluation. And then we mentioned stakeholders earlier. They may have less experience than you with AI over time. So you need to engage them, as well as your other clients, in the design, implementation, and use of your AI systems. Undoubtedly, they'll have questions, not only at the end, but hopefully during the process. And so you need to solicit their opinions and find out what their expectations are. And then a lot more reflection on your own practice and values and how AI affects or aligns with them. You may decide it's not worth it working with AI, and you may just want to continue what you've been doing without AI, which I'm sure has been great for many people. But as I hope you understand, I think AI is with us and will have a very important role to play in the future. So there's some references I've come across which I think should be helpful for you. First, there's the website Merle Tech, which focuses on monitoring, evaluation, research, and learning, and is looking and spending time on webinars on AI. So they have a lot of resources available. I encourage you to go to their website. And we must not forget the guiding principles for evaluators that the American Evaluation Association has. And again, their website here. And then finally, just a few months ago, the UN has an AI advisory body, and they issued a report about the governance of AI called Governing AI for Humanity. I encourage you to look at that, mainly because governance is going to be a key issue as well. We've talked about all this sort of the details of the AI in at least in one respect, but there are going to be questions about what can or can't be done, say with intellectual property, and people are going to demand some sort of governance. It could be at a state level in the US or a country level or an international level, either at the UN, the World Bank may get involved, International Energy Agency. They will undoubtedly get involved, and they're key issues that are being addressed or will be addressed, and I encourage you to look at this report as well. Finally, to some concluding thoughts. Are there special program evaluations that should not or could not be done using AI? I don't have an answer for you on this, but I think you should think about this when you conduct your evaluations and whether you should be using AI or shouldn't. And then, as you can imagine, we're just really starting to look at this in terms of AI and how it's being designed in program evaluation and what does it look like. And I think we need to compile examples of this now going forward. We've done compilations of evaluations of energy programs, say in California, but I think it's important to see who is going to be involved in this and seeing whether they'll be able to compile this. It's nice to have. I can tell you from my decades of experience in program evaluation, you can go to a site and find out examples of studies, whether it's residential, commercial, industrial, whether it's in schools, whether it's process evaluation, impact evaluation. It'd be nice to have this compiled, either in existing ones, or we may need to develop a new one. So I think that's all I wanted to say. If you have questions, feel free to email me or today in the chat. And also, I think it's important that we continue the community. I hope Energy Evaluation Asia Pacific will continue presenting more webinars on AI. So with that, I'm going to stop sharing and hand it over to Anindita.
Thank you, Ed. Thank you very much. And also for the resources, for the questions you raised in the end, and for setting the stage beautifully for us. I would like to invite Haidar, and just as a reminder for everyone who's here today, please, as you listen to our speakers, if you have thoughts, ideas, comments, keep chatting them in. We would like to see where you are with your thinking on these issues. And if you have questions, let's bring them up in the panel afterwards. The next speaker is Haidar, and Haidar Khan, let me do a better introduction than the last one that I did. So Haidar is the Vice President with Energy Analytics for Energy Analytics at ICF. He has more than 22 years of experience in energy, econometric and mathematical modeling, simulation and optimization for utility and government planning and policy development. So in his work with both the public and the private sector, Haidar and his team use cutting-edge technology and are using AI applications for energy evaluations of several types. Haidar actually will bring in the perspective to this discussion from the work they're already doing and where he sees the future going. So very excited to hear from you, Haidar, and welcome. The stage is yours.
Thanks, Anindita. Thanks for the kind introduction. And thanks, Ed, for putting the context that will help my presentation. First, a disclaimer. So since we're on the topic of AI, I asked Copilot, which is Microsoft's AI agent, and it leverages OpenAI's large language model to create some of these slides. And then the icebreaker question that Nazir put forward. So my hope with AI is that it will help it will help us overall as an industry solve really complex energy problems that are coming up faster, more accurately, and at scale. And some of the work that I'm going to present to you today is along those lines. Next slide, please. So in this presentation, we'll explore the role of artificial intelligence in energy programs and policies. We'll start with an introduction of AI, which Ed did a pretty good job of, but I'll talk a little bit about it from my perspective. And then we'll delve into some of the current trends. As Anindita mentioned, we are applying AI quite extensively in our energy work. I'll give one example of that, and happy to answer questions around that after. And then finally, I'll talk about what I'm seeing evolve in terms of AI in energy in the next 4 or 5 years, which is very exciting. So with that, let's dive into it. Quick level setting again. Overall, AI is quite a broad term, and it's being used quite colloquially to refer to everything and anything that essentially refers to a computer trying to mimic a human, which is an appropriate definition of it. But there are many sub-branches, there are many subsets of that. One of them is machine learning. Another one is the deep learning. What is getting the hype is the deep learning, and I'll talk about it in a second. But AI, you can think of any computer algorithm that tries to mimic a human, which can be as simple as an if-then rule, could be as complex as the large language models that we are seeing now. Machine learning, which is a subset of artificial intelligence, it essentially refers to statistical techniques that are used to enable machines to learn from basically the past issues, past errors that are surfacing as a part of the evaluation, going back to this topic, and essentially use it to improve over time. And then deep learning, this is where, as I said, all the AI hype is right now. It is trying to essentially mimic the organic brain function. And it's using these artificial neural networks, which are, again, very similar to how the human brain and other organic brains work. It's essentially exposing those artificial neural networks to large amounts of data, very large amount of data, and in the hopes that it will form models that are generative in function, essentially that will help generate. So that's the reason for the name generative AI. And I'll talk about each of these and how we are applying them to solve complex energy and evaluation problems. Next slide, please. So as I said, I've broken it down into 3 areas: what is happening now in terms of machine learning, what's happening now in terms of deep learning, how we are innovating and bringing it all together to solve problems, and then where we are seeing it go from here. So this is a reminder. And then, so let me start with the current trends in machine learning. Machine learning, I mean, this has been going on for a while now. It has, I actually took my first machine learning course back in 2010, and those algorithms at that time were quite advanced in terms of what they could do in terms of mimicking a human to solve complex problems, such as in energy, specifically forecasting, ongoing operation optimization, and evaluation. Forecasting, there are many flavors of forecasting. And in the energy industry, in the utility side of things, there are forecasts that are needed both on the supply side and the demand side. So the supply side being the generation, transmission, distribution, the demand side being where the customers are leveraging all of that energy being produced and using it for different purposes, including different sectors: residential, commercial, industrial. So the forecasting that we have been doing using machine learning has been helping us on different, help us solve different types of problems. There are these longer term forecasts that are needed, like the next 30 years, in terms of policy setting. How do you set your targets to get to a certain objective? Say, for example, decarbonization. What machine learning is helping us forecast what scenarios, what different futures look like under different types of conditions that we are seeing happen in the industry now and evolving over the years as markets transform. Then there's the shorter term forecast, which is more done for the designing once the planning is done to design programs. So that is like the next 3 years, next 5 years on how to set in motion these programs that would help us get to that policy that's planned for the next 30 years. And then there is the shorter term forecast of actual implementation, which essentially is how do I now take this design and actually implement it, and what type of, say, for example, how many heat pumps am I expected to get because of the seasonality difference in the next month or in the next week. That's where machine learning is coming in to help us forecast based on, again, the regression variables such as not only weather, but things like what is the market availability, what are the cost variations, those types of variables, and then use it for forecasting that. And then all of that is also forecasting, is also being used for operational real-time operational aspects. And I'll talk about an example of that, so I won't go into too much detail right now on that side of things. But there are ongoing operations optimization that we're using machine learning for. And then topic of the day, evaluation. Absolutely, machine learning algorithms are being used and have been used for a while now to do better evaluations, and not only you do evaluations, but connect the outputs of evaluation back to doing the forecasting, back to learning from it to improve all the aspects that I talked about, the policy side, the planning side, the actual implementation side. So with that, I'll move on to deep learning. The next slide, please. So deep learning, I'll give a little bit more of what is happening, but it's all around in the news. This is when people say AI, what they are talking about is essentially deep learning. And what deep learning is, as I mentioned, is taking these artificial neural networks, exposing them to a large amount of data, and then learning from it, but to a point where they can now generate information. They can generate images, they can generate videos, they can generate documents. As I mentioned, I generated some of these slides using generative AI, which is deep learning, essentially large language models. And they are being used a lot in all of those aspects that I just talked about, but they are also being used in energy. We are currently using deep learning in several aspects of the energy programs, policies, planning, marketing that we are doing at ICF for using AI. And these include things like some really cool, cool looking videos that are being generated through avatars. So instead of a live human talking, you have an avatar that you feed in a script, and it basically sends the message out, and it could be a personalized message to someone with the avatar basically speaking, and hard to tell if it's a real person versus a computer generated video. That is actually quite a hit, and it's very well received by the industry because it's solving a lot of complex issues that we have around marketing. We're using it for incentive processing. Incentive processing is where you get a receipt from a trade ally, for example, or a customer saying that, okay, we paid this much incentive, or we paid this much amount of money for the overall system, and for this part of it was the incentive. And some of those invoices are formatted in shapes and forms that are different than other invoices. So AI is now what we are using to determine, put it in a structured format that we can then query. So putting it in tables is from say a PDF document or a picture of a document is where we're using it. Anomaly detection, where we have outliers or we have potential issues around incorrect invoicing, as an example. That's another area where we're using this deep learning AI side of things. And then again, topic of the day, energy reporting, evaluation, filings. We generate a lot of documents now already using these deep learning models, more specifically large language model that Microsoft makes available as a part of their overall environment, Copilot. We obviously there is a lot, as Ed indicated, you have to be very careful with what you use it for. Humans have to be in the loop because it does hallucinate. It does. We have seen firsthand all the issues that it's causing. But at the same time, it increases efficiency quite a bit. We can feed in a bunch of documents to it and have it create another document that then is used as the starting template, which would be better, or which is better than what we have been able to produce manually in the past. So it does improve our efficiency overall. So that's what's currently happening in terms of deep learning. But there is a field of deep learning, artificial intelligence, that is burgeoning in the energy industry called digital twins. And I'll talk about that in the next slide. Can you please move to the next slide? Yeah, so this is kind of an innovation that we at ICF have been at the cutting edge of. We've deployed all this deep learning, all this machine learning, and our understanding of the energy systems to create these digital twins, which basically are a representation of the physical world and as close as you can get to the real world system. And these digital twins can be, we actually have it for both the supply side, so that again, the generation, transmission, distribution system of the electric system or the pipes of the gas network system. And then we also have it for the building side, the demand side. This is where it was really impossible, I would say, to get to just a few years ago, before the advent of deep learning, machine learning, cloud computing, all this data that is now available through IoTs and smart meters and all of that. But this is what we have been able to accomplish. We now have digital twins that we use for that we create, first of all, for every single building in a jurisdiction. For utility, the largest number of digital twins that we've created is 2.3 million digital twins that represent every single building in a utility jurisdiction. And then the distribution system overlay on top of that, so that we can solve for these various aspects of the energy industry that include longer term forecasting, as I talked about, designing programs that are very specific, use very granular information, and then use the same stream of data for actual implementation and evaluation, and then have it all connected such that the evaluation part is used to learn quite real time and use it to improve the forecast, improve the design, improve the implementation. So that's where things are in terms of the digital twin. Let's switch to the next slide, where I talk about an example of how we're using this digital twin for a very specific challenge. Some of you being in the industry may have heard all the changes that are happening in terms of energy use and decarbonization efforts and electrification that comes along with it, all the EV adoption. What that is leading to is a very different paradigm in terms of how energy is being used, how energy is being delivered, how energy is being generated and supplied. One of the big problems with that is that the grid is getting congested in areas where there is a lot of growth. AI is part of the issue here, the amount of energy needed to train these models is huge. And it is causing these systems, these grids and demand to spike quite a lot. So the challenge that we were helping solve for our client is that how do you manage this congested grid, and how do you locationally, with a very specific feeder or substation, manage it? The way we do it currently, and we've deployed it across a number of utilities in North America, is that we create, again, these digital twins of every single building that has a smart thermostat or a battery or EV system on it. And then we use, sorry, still the same slide. Then we use that to forecast the next day, the next hour of how the building would operate if you were to dispatch those signals to those buildings. And every building is different. Every building has a different characteristics in terms of the energy use and energy features that it has. So that's why a digital twin was necessary. We then use it to orchestrate a dispatch, and then that is then sent to those devices to actually have an impact on the grid when the grid is going to be congested as a result of some weather event or some change in the energy usage or some market condition. And then right after that, we can evaluate using, again, the same digital twin technology, the same deep learning, artificial intelligence technology. We can evaluate what the impact of all of that was and improve our forecast for the future to improve our dispatch orchestration. So this is all how AI is being used with some innovations currently. I'll move to the last slide, which is how we are seeing it evolve in the future. I mean, large language models are evolving very well. They are basically putting in more data and getting better results out of it, or they are trying to find the optimal amount of data, they being the researchers and the stakeholders, finding the right amount of data that gives you the best results. And there are now some open source generative AI models as well, which use smaller amount of data, but they are trained in a way that they're still responsive and good enough. But what is happening on the energy side in terms of the deep learning is very exciting. What we are now, what I just explained about the digital twins, it requires a deep understanding of the laws of physics that impact a building. So you need to understand heat transfer, thermodynamics, fluid dynamics, all the equations that govern all of those principles, and then convert that into code and then solve those equations simultaneously. All of that, as you can imagine, takes a lot of computational energy and time and resources. What things are moving to is kind of a large language model that would solve all these equations in a way that it is generative in nature. So you expose it to new equations and it will solve those equations in a deep understanding manner. So this is where things are moving, and what we are seeing is that this will help us do all of what I just explained in a much more efficient manner at very even larger scales and in very short periods of time. With that, I'll stop. That's basically what I wanted.
Wonderful. Heather, thank you. That was remarkable. So thank you very much for sharing that. In the interest of time, I think we need to move on now to Laura's presentation. And welcome, Laura. Let me do a proper introduction of Laura as well. So Laura Gagliardoni is an M&E practitioner, and she has more than 16 years of experience across, I'm going to say, 7 UN agencies and several NGOs. She has a lot of experience in implementation, and she's thought about and worked through these AI and other issues extensively. So sharing her experience of evaluations in general and AI, not energy evaluations. Now here's Laura.
Thanks, Anindita, for the introduction and for having me. Hi, everyone, and welcome. So I'm happy to present the evaluation insight I have prepared for the EVAL SDGs network on quick tips to assess the risks of AI applications in monitoring and evaluation. Next slide, please. So we have already defined artificial intelligence, but I will take the opportunity to recap what we have said and perhaps add a few definitions. So it may be defined as intelligence, perceiving, synthesizing, and processing information demonstrated by machines as opposed to human intelligence. It adapts to meet users' needs by analyzing usage patterns across diverse data sources or general guidelines within a vast information landscape. It undertakes tasks requiring human intelligence, including visual perception, speech recognition, and language translation, but is not a new phenomenon, having been utilized by organizations for over 30 years. However, recently, multilateral organizations, governments, academia, private sector, but also security and law enforcement agencies have taken an interest in incorporating AI into operations and the evaluation discipline. But despite the operational benefits, unfortunately, AI applications pose some risks. Next slide, please. So what is the issue I would like to present today? That AI has leveraged big data and data sets to inform decision-making through trend and pattern analysis, and has supported crisis identification and disaster preparedness. So for those of you who are familiar with the 2030 Sustainable Development Agenda, I'm referring to the Sustainable Development Goals 11 and 13. AI has also revolutionized diagnostics and treatment in the health sector and been instrumental in real-time monitoring and reporting in agriculture and education. But the utilization of AI in M&E poses several risks. For instance, bias and fairness. AI can inherit biases from the data they are trained on. Data misinterpretation. AI may misinterpret data or produce misleading results if the input data are flawed. Privacy concerns. AI may process sensitive personal data, raising concerns about the privacy violations and unauthorized access. Security vulnerabilities. AI could be vulnerable to hacking, leading to data breaches or manipulation of evaluation results. Ethical dilemmas, reliability and robustness, and also over-reliance on technology. AI could lead to a diminished role for human judgment and oversight, potentially undermining the quality and the credibility of evaluations. So here there are some examples of AI applications specifically related to the monitoring and evaluation of the SDGs implementation. So we can use AI, for instance, through web search engines like Google Search, generative or creative tools such as ChatGPT, Claude AI, remote sensing, big data analytics, blockchain technology, computer vision, natural language processing for textual data analysis, or machine learning for large data set analysis of SDG indicators. And AI applications are also utilized by development and security law enforcement experts. For instance, there are data management capabilities for processing and categorizing information and monitoring dataset access, predictive analytics, which we have already discussed about, to analyze emergencies and threats, aiding in risk management and the development of early warning systems. Risk mitigation through AI algorithm, identifying behavior patterns related to past incidents, and the fraud detection, using machine learning models focused on text mining, social media analysis, and database searches to reduce fraud threats and streamline financial processes. So here I would like to share a few AI solutions which were developed to improve evaluations or programming. So here we have the ADA, the Artificial Intelligence for Development Analytics, which was produced by the United Nations Development Program Independent Evaluation Office. ADA cuts straight to the evidence, and you can actually search evaluation reports within the database of UNDP that includes more than 6,000 UNDP evaluation reports. And to start, you can simply type a keyword or filter evaluations by region, topic, or relevant SDGs. And these wouldn't be possible without AI. Here there is another example, which is the UNDP India Accelerator Lab, that in partnership with the University of Nottingham is actually developing the Geo AI platform to help environmental regulators act on non-compliant brick manufacturing units and address air pollution. So this innovation is unique and utilizes artificial intelligence, and it's very important for environmental regulations. And this is the model that I have conceptualized to share a few tips to assess the risks of the AI applications in monitoring and evaluation or in any other operation. So the model is structured in 4 steps: framework analysis, data collection, model development, and monitoring and evaluation. So let's look at each of these steps together. So the first one is the framework analysis. So it's very important to review existing legal frameworks and regulations related to AI in your country. It's also important to identify regulatory and reputational risks for your organization, conduct a risk assessment based on current frameworks, trends, values, future goals, and objectives, and use it to determine what data you need to collect and how you want to analyze them and process information. A very important point is to involve diverse stakeholders in the risk assessment process since the beginning. So for instance, AI developers, domain experts, policymakers, and end users. I've also suggested a guiding question for this specific step. That is, what are the frameworks, rules, regulations, values, and future goals and objectives of your organization? The second step is the data collection step. So it's important to choose the data sets which are suitable for AI model processing and which ones to discard. And then plan where you can actually find reliable and quality data. Check the data quality, integrity, and readiness. And also pay attention to some important ethical considerations. Address issues related to AI fairness, transparency, accountability, and responsibility. And also consistently evaluate privacy and security to avoid data breaches or invasions of privacy. For this second step, the guiding question is, are these the right data sets for a potential AI application? What are the ethical considerations I should take into consideration? The third step is a model development. So it's important to consider whether the AI tools you are planning to utilize can concretely help monitor and evaluate, for instance, the implementation of the SDGs, but also any other operation. It's important to review any regulatory limits on how AI can be used for certain processes, assess how AI will help your organization advance the monitoring and evaluation of the SDGs implementation, and promote awareness about AI risks within the broader community. Also, finally, consider costs and benefits for your organization and the sustainability of the utilization of AI to conduct evaluations. The guiding question is the following: is this AI application suitable for your evaluation? The last step, the fourth step, is the monitoring and evaluation. It's extremely important that the implementation and use of AI are consistently monitored, evaluated, and adjusted, that you evaluate the potential impact and also utilize evaluation findings and recommendations to prepare a catalog of lessons learned and good practices of AI applications. This is an advice, a suggestion that I provide to all organizations. It's very important to build institutional memory around AI practices. So if you have good examples, it's important to prepare a catalog so that you can think of replication or upscale, and eventually even innovation. So the guiding question for this specific step is this AI application effective, efficient, impactful, and coherent with the values, goals, and objectives of your organization? So here there are three key takeaways I wish you could bring home. So the first one is that AI enhances evaluations by analyzing data and informing decisions across various sectors. But unfortunately, AI in monitoring and evaluation poses risks such as biases, privacy concerns, security vulnerabilities, and others, which we have covered during the webinar. But the good news is that there is a possibility to mitigate those risks by implementing ethical protocols, monitoring AI performance, and maintaining human oversight in monitoring and evaluation. So the good news is that the human capacity is still relevant in this new time of AI. With this, I would like to thank you for your attention, and if you have questions or insight, please don't hesitate to contact me. I would like also to invite you to read or download the evaluation insight, which I've written and is available on the Eval SDGs Network website. So thank you, and with this, over to you, Anindita.
Wonderful, Laura. Thank you so much. And also, I also want to point out, thank you for sharing your framework and some of the resources that you pointed us to. Very helpful indeed. We have about 13 minutes until the close of the session. But it is important to check in with our audience. And there is one question. I think this is likely for Heather, and this is about the digital twins. Heather, I will read it to you. It's Jean-Sebastian's question. And the question is, has the digital twins approach been used to test how non-wire solutions can substitute network investments?
Yes, the answer is yes. And actually the platform that we use to that we're currently using to solve all these problems was first developed to solve what is generally referred to as in the industry as a non-wires alternative. So essentially you look at if you can mitigate issues around congestion using these different resources that are on the demand side, such as storage, batteries, or energy efficiency overall. So you compare the benefits, to Laura's point, you can compare the benefits to the costs and see if it makes sense to do those in a non-wire manner or not. And if you could defer the wires option to a certain point, or you can even completely remove that.
And there is a different question for you, Heather, from Rowena. And the question is, have you seen applications of these AI techs in other types of grids? Example, smart grids, distributed generation, etc.
Yeah, so to be able to forecast how much generation is going to come on from these prosumers, how much will be injected into the system, or how much can be used for arbitrage, as in like you don't use energy from the grid, but you generate it and use it yourself, and that would help alleviate the issues on the grid. All that forecasting is done using these digital twins that I was talking about.
Thank you. So there was a question which had come up even before our forum started, that more came from our community, people who couldn't attend. And the question is, what do you, this is Laura, Haidar, Ed as well, whoever would like to jump in, what specific applications or toolkits would you point evaluators toward if they want to bring AI into their work?
I don't know. I'll defer to the others.
I can mention one. There is a open source framework available from California Public Utility Commission called CalTrack. It's a source, and it's also available at the Linux Foundation website. And essentially, you can use that to do all sorts of evaluation of even high interval data. And then this is where you can apply AI, is to essentially use that to create a machine learning loop that then connects to the system that you were using it to mitigate any energy related issues. The example that I gave in terms of the dispatch orchestration. So that is what we actually have in our system. We use CalTrack to evaluate the system's performance and then tie it back to the dispatches to improve the system.
Thank you, Heather. Is that a link you could share with us later after this?
Sure.
That would be amazing. Laura, what would you suggest?
Yes, so thanks, Anindita. I suggest, for example, the utilization of ChatGPT. Of course, it requires a human oversight, but it can be extremely useful to review the report, to check some terminology, or even to generate the evaluation recommendations, right? So for better future programming. There are other opportunities, for instance, the utilization of geospatial data. So nowadays, evaluators tend to utilize new data sources, right? So geospatial data to geolocate where, for instance, programs happen. I remember when I was working for UNICEF, UNICEF Division of Data Analytics, Planning and Monitoring, we utilized the geospatial data to geolocate, for example, some of the hotspots in Ukraine during the war. These also can be utilized, incorporated in evaluations. And also, for example, the utilization of AI and mobile data, as a new data sources, frontier data to improve the data quality and the data diversity in evaluations. Thank you.
Thank you, Laura. Actually, there is a question for you, also from John Sebastian. And the question for you is, thank you for the interesting presentation and mentioning the risks. You talked about the ethical risks. Do you consider also the resources, energy materials needed to run AI tools against the added value these bring?
Yes, we can certainly evaluate also the resources, meaning even financial resources, human resources, and an important observation I can share with you, is that nowadays organizations really need to evaluate what capacities they need to bring in on different teams. So teams have to include, for instance, a monitoring and evaluation specialist, but also a data specialist, eventually an expert in AI, a program coordinator. So, there is a kind of a change worldwide in terms of the mix of teams, right? To bring a different expertise together and make sure that, programs or strategies are better planned. So yes, of course, it's important to evaluate resources. Thank you.
Laura, thank you for that. Just one thing, my connection is a little patchy. So I actually missed a bit of that, but more importantly, I hope everybody else got to hear it. I have a question for all of you. And my question is, when you talk about, when you look at this, obviously, just judging from the examples that Haidar gave, and what you're talking about, it already feels like the future is here. But there is a big diversity in where people are experiencing AI. And so when you look at this, what do you think is most important, the most important capability a person, individual, or organization must have in order to interact with or leverage or use AI?
I'll go first.
Sure.
Education. I think we're still at the beginning of all this. And I mean, I learned a lot today, and I'm sure if I listened to more, I'd learn a lot more. So for an organization, no matter where you live in the world, I think there will be some experts, perhaps in your country, but there'll be experts around the world. So I think we're going to see an increase dissemination of information, but I think there's still going to be an increasing need to answer individual questions. So hopefully there'll be forums where people who are starting to get involved in this can ask the experts these questions. So I again focus on education as playing a critical role.
Thank you, Ed.
I would say that, yeah, I would agree with Ed that once you are educated, once you know the possibilities, once you are ready to deploy all of that, especially in energy, it's important to be sensitive to the data privacy issues. It is something that you can get a lot of information from, and that could be used in a with a malice if those are the intentions. So data security, data privacy concerns should never be undermined.
Thank you, Haidar.
On board, and also knowledge management. So it's important that you know, the progress that any organization does in terms of incorporating AI, whether it's a good or bad experience, is monitored and tracked. So that builds institutional memory and also, you know, allows the personnel to actually learn lessons and hopefully, you know, build capacity. Thank you.
Thank you. One last question in the last 1 minute. So just if you would think as I read it out, how difficult is it to train AI tools? And would you recommend to use the standard evaluation tasks? Would you recommend AI to use the standard evaluation tasks?
I think training AI tools is not a trivial task. We actually haven't been able to train many. To be honest, it requires a lot of iterations, a lot of resources, and the need for training is being minimized through the commoditization of these tools. There are as everybody knows, these large language models are now available quite ubiquitously, such as like ChatGPT. But then there are image processing, video processing. There's a whole list of these tools that have been commoditized that doesn't require you to train anything. In terms of if you were to say put a RAG, which is a augmented generative tool, and use it only on your data. Microsoft provides an environment in Azure, and so does every other cloud provider, to be able to put it in a way that you don't actually have to go through the large language model learning, but you can have the large language model that's already train on a sub data set that is yours that you can then use to query.
Thank you. So it's pretty much the hour where we must end. There is another comment here. What we will do is we'll follow up with Brooker Thank you for the comment. We'll follow up if need be. But I would like to bring this session to a close, noting that it's nearly not enough time to have this discussion. And thank you once again to Ed, Laura, Heather, Nazir, and everybody who was here today to contribute. We hope to continue this discussion as we go on. I learned a lot, as I'm sure others did too. And on behalf of EEAP, once again, thank you and have a lovely rest of the day or rest of the evening, etc., wherever you're at. Thank you.
Thank you.
Thank you, everyone. Bye-bye.